Hello, so in today's video, we're going to look at sketching the three, I guess, main trigonometric functions. So sine x, cos x, and tan x. We're going to sketch these three graphs. And the key thing today is that we're going to use x in radians. We're going to use kind of like the standard units for angles in advanced maths, which is x being in radians in these trigonometric functions. So yeah, we're going to start by sketching y equals sine x. So this is again probably a graph that you would have seen. So when you plug in x equals 0 into sine 0, you'll get a 0. When you plug in x equals pi over 2, so remember pi radians is 180 degrees. So pi over 2 radians, that would be 90 degrees. So when you plug sine 90 or sine pi over 2, when you change your calculator into radian mode, you'll get the number 1. So you get 1 up that. When you plug in sine pi, so sine 180 degrees, if your calculator is in degrees, you'll get 0 again. And then sine of 3 pi over 2, which is 270 degrees, you get -1 now. So now that becomes -1. And then 2 pi, that will get you 0 again. So your sine graph kind of goes in this kind of wave, sine wave shape. So you get a sine wave like this, roughly. Something roughly like that. So that's your sine wave. And the key thing with this sine wave is that the period of this sine wave is going to be 2 pi radians. So basically the wave repeats itself every 2 pi radians. So the shape is literally repeated in a time period of 2 pi radians. So your period for your wave is 2 pi radians. So that's your time period. So that's just a key thing to remember. Yeah, wave repeats itself. So repeats itself every 2 pi radians. So essentially what that means then, I mean, if we go to a new page, so if you've got a graph, your sine graph like that, so that means that let's say you've got a value there of pi over 6, and that gives you some value. I mean, the value there should be a half, but we'll come on to why that'll be a half in a future video. What that means is that if you add on 2 pi radians, so if you add on 2 pi radians there, this is going to be pi over 6, sorry, my bad, pi over 6 plus 2 pi radians, and that gives you exactly the same value as this value here. So basically the sine graph repeats itself every 2 pi radians. So again, your period is going to be 2 pi. So you've got 2 pi radian period. Something else I'll also talk about with the sine graph as well is that between 0 and pi radians, so pi radians is in the middle there, 0 is there, you have a line of symmetry. So you have a line of symmetry on this line there, if we just ignore everything from here for now and everything there. So between 0 and pi, you have a line of symmetry at pi over 2. So again, that means that if you've got an angle there, let's say pi over 6, and this gives you some y value, again, that y value is actually going to be a half, but again, we'll come on to why pi over 6 gives you a sine value of a half soon in a different video. But we can see from the line of symmetry there that we get another angle on the x-axis, which gives us a sine value of a half. So to get this angle here using the line of symmetry, we can just say that that is going to be pi take away pi over 6, and that would actually be 5 pi over 6. And again, the reason for that is because the gap between 0 and pi over 6 there is pi over 6, and the gap between this number there and pi, the number pi there, should also be pi over 6 because of this line of symmetry in the middle. This part of the sine wave is symmetrical, so you get a gap there of pi over 6. So pi take away the gap of pi over 6 will get you this angle 5 pi over 6 there. So that's just considering how you can consider the periodicity of the sine wave, and how you can consider also the lines of symmetry to get other angles as well. But let's move on to, so yeah, that was our sine graph. Let's move on to our cos graph, so our cos wave. So when we start with cos 0 is actually the number 1, so we get 1 up there. Cos pi over 2, so cos 90 degrees, that's going to be 0. Then cos 180 degrees, or cos pi radians, that's going to be -1. And then cos 3 pi over 2 is 0, and cos 2 pi, which is 360 degrees, is again number 1. So you get kind of a wave like this. So this is your cos wave. So I'll try that again, going through all these points here, touching down there, going through there, and back up like that again. I'll try that again. Something more like this. There we go. So that's our cos wave. So with our cos wave, again, we've got a period of 2 pi radians. So the graph is going to repeat itself every 2 pi radians because the graph continues like that, and therefore it's repeating itself every 2 pi radians. So every 2 pi radians, the graph repeats exactly the same shape. So that's our time period. And again, we've actually got this line of symmetry down the middle between 0 radians and 2 pi radians. We've got this line of symmetry at at x equals pi. So that means, again, if we pick like a random angle there, let's just call that x as a random angle, and we get some random cos value, that means that this other random value there, this number here, is going to give us exactly the same cos value on the y-axis there. And this number, because of the line of symmetry in pi, in x equals pi, again, that means that the gap between here, so the gap between these two numbers here, must be the same as the gap between 2 pi and that number there. They must be the same gap because of this line of symmetry. So that means that this angle there is going to be 2 pi, subtract the gap, and the gap is x in this case. So actually, again, yes, you can use the line of symmetry to work out other solutions on the x-axis, which will give you a similar y value. And again, the period of this graph is 2 pi. So in fact, you can also add, to get this other solution here beyond 2 pi on the x-axis, you can just add 2 pi to x, so 2 pi plus x. That will get you your other solution there. So that's how you can use the cos graph. And then the tan graph, so y equals tan x. So tan 0 is actually 0. Now tan pi over 2 is undefined. So the reason for that is because, again, we'll come on to this again soon, but we've already really mentioned that tan is the same as tan x is the same as sine x over cos x. And we know that cos pi over 2 is 0. And when you divide by 0 in maths, that's undefined. So the tan graph looks something like this. So it increases between 0 and pi over 2, and then asymptotically approaches this asymptote. So again, we've got this asymptote here. So asymptote, let me try and spell that better. Asymptote. And again, from this side, the graph kind of goes like this. So it starts negative, goes through pi, and when you put tan pi radians in your calculator, or tan 180 degrees, you get 0, and then it goes, it continues up like that until we get this another asymptote here. Sorry, this other asymptote, and we get another one there, and then again it repeats itself until 2 pi radians, when again tan 2 pi radians gives you 0. So we can see with this one that the period of this graph, this tan graph, is actually 180 degrees. So in other words, pi radians. So the period of this graph is pi radians. So the graph repeats itself every pi radians. So let's say you've got a random x value there, and this gives you some random y value there. If you add 180 to this, you'll get this other solution here. So this is just going to be x plus pi, so x plus 180. And again, it just repeats itself every 180 degrees. So you just add another pi to it, and a pi to get your other solutions beyond 2 pi radians. So yeah, the period with this graph is pi. There's no line of symmetry in the vertical direction, so we don't need to worry about other solutions like we did here, for example, with this cos graph, where we've actually got another solution here before we add 2 pi to the original x value, because we just got this line of symmetry, which means actually we got this extra solution, this 2 pi minus x value here, which also gives rise to the same y value. So we just want to be careful with the cos graph and also the sine graph as well, because again, with the sine graph, we've got lines of symmetry here between 0 and pi. We got this kind of line of symmetry here between pi and 2 pi. So you just want to be careful to do pi subtract your x value here. So again, if you got an x value there, let's say this is y. So what other x values on the graph give you the same y value? Well, we can go here on the sine graph. Again, because of the line of symmetry at pi over 2, that means the gap between 0 and x must be the same as the gap between that number and pi. So this must be pi take away x using the line of symmetry. So again, yeah, that's just a summary of how the cos, sine, and tan graphs all work. what their periods are, their time periods, and some information about lines of symmetry that you can use to find other values on the x-axis, which give you the same y value as what other values on the x-axis may also give you.